In this video, we're going to talk about basic concepts of organic chemistry, specifically functional groups. We're going to go through what is a functional group and examples of functional groups you're going to encounter in your A-levels, especially the first year of A-levels. We're going to look at what those functional groups look like, just to give you an introduction, and then go through, in a bit more detail, some aliphatic, aromatic, and alicyclic types of compounds. So just to introduce you to functional groups. So we're going to highlight two functional groups. There's actually kind of three in here, but there's two we're going to highlight specifically. And this is ibuprofen, which is a drug, anti-inflammatory drug. And these functional groups, they will react in the same way. So they're part of that molecule that reacts in the same way, has characteristic reactions. Now, if that is the case, we'll look at this. Where can you see characteristic parts? Well, the functional group here, first of all, there's an alkene. And that alkene, that will react, for example, all alkenes react with bromine under different conditions. But they react with bromine, so I would expect this to react with bromine. We then look at this one and we can see a carboxylic acid. So we would expect this to react with bases, because it's an acid. It would react with bases, it would react with bromine. And also, just to introduce you here, this is a benzene. And that has characteristic reactions as well, and that's 3 double bonds within a hexagonal structure. So we're going to go through different functional groups and introduce you to different functional groups before we start then drawing our aliphatic and aromatic and alicyclic compounds. So that here we've got two functional groups, the alkenes and the alcohols. And we're going to use this to get you used to drawing different types of organic molecules. But before we do that, we're just going to go back to this homologous series. So in a previous video or in your lessons, you know this has the same functional group but differs by CH2. So basically it gets longer. So it keeps that functional group but then gets longer, and different molecules have different lengths. Now, if that is the case, we can look at alkenes and we can look at alcohols. So if I'm looking at alkenes, hopefully you remember from GCSE that you're looking for a double bond. So 2 carbons, double bond between the carbons. Each one of these I'm going to draw as skeletal forming to show you, and some of them I'm going to get you to name, because hopefully the ones in GCSE definitely I'll get you to name, and then I'll tell you the names of the ones that are new. So this one, there's your double bond, and then there's your skeletal formula. So that is 1, 2, 3, 4. What do you think the name is? Think about it, maybe write it down. Okay, so that 4 is bute. Okay, and it's at position number 2. So the alkene is position number 2. That's 1, that's 2. Right, we then go to alcohols, and we're going to use this to introduce the term R. So the alcohol group is ROH. So ROH. So what is R? R is a alkyl group usually that you define what it is. So you can define what it is. So if you're going to put R, then you can say, right, okay, R in this case, and we're going to invent an R for this one, and we're going to say R is CH3. But you can call R anything. You can say R is CH2, CH3, CH2, CH2, CH2. So you can say R is a methyl group, R is an ethyl group, R is a propyl group. R can be anything you want as long as you show what it is. So that means if that was R and R is CH3, this has 1 carbon. 1 carbon is meth. Okay, so 1 carbon is meth, and alcohols end in ol, so it's methanol, if that was the case. But the general formula is ROH. Now, let's just finish this off actually. Remember there are 4 bonds to the carbons, just want to make that clear. And then move on to our next one. So our next one is carboxylic acids. So we've seen carboxylic acid on the previous one. And a carboxylic acid, for example, let's use the R again. And there's your R, and it's got a double bond here. This is known as a carbonyl. It's not a functional group, but it can be called carbonyl, Ca. So that can be called a carbonyl. And this bit here, and you'll learn a lot about that later in the course. And then that carbonyl is bonded to an OH. So for example, again, if R was CH3, so we're going to say R is CH3, so let's look at this. R is CH3, hopefully you remember from your GCSE. And look at R, well, how many carbons does this have in it? It has one CH3, one carbon there, and then 2. So it's got 2 carbons in it. 2 begins with eth, and that would be ethan, and then the ending of carboxylic acids is oic acid. Okay, and that would be our example with this. So we're going to go on to haloalkanes. So haloalkanes is about the halogens. So everything in group number 7. So again, we can use our R, and we can go R, and sometimes they refer to this as Rx. Now X just equals a halogen, okay, of some type. So halogens are in group 7, that means fluorine, chlorine, and then bromine, and then iodine, and then astatine, but we don't really use astatine in most equations. So if that is the case, and we have that halogen, let's make up one, and let's just say, right, okay, this is R, and we're going to do Cl. So RCl, well, that R is CH3 again, so that means 1, so this is 2 different ways. You can call it this time, use the chloro, and use it as a prefix. Okay, so all haloalkanes, the halo bit, as it's written here, you can see it's written here before. Okay, so it's written as a prefix. So this would be called chloro. And because our R is CH3, it would be chloromethane. Because the chlorine just comes off this CH3. Now again, this is only an introduction, so do not worry. We're going to go over this in much more detail in other videos. Now these are totally new. So totally new, which is aldehydes and ketones. Now aldehydes are our carbonyl. So there's our carbonyl again. And then there is just a H coming off there. Okay, and if we do that in skeletal formula, for example, it would be R and then H. It's the only H, or one of the few H's, sorry, that actually is drawn with skeletal formula. So here you have your aldehyde, and that ends in al. So if that was here, again, one carbon there, or one carbon here, the same thing. So that means 2 carbons in total. So that would be ethan, and aldehydes end in al, so ethanal. We then go to the ketone, and the ketone is R, C, and there's your carbonyl again. And it has 2 of these R groups, 2 alkyl groups either side. So it must have 2 alkyl groups either side. So that in total, okay, if you think it's CH3 there, so 1 carbon there, 1 carbon there, 3rd carbon there. So 1, 2, 3 carbons. So 3 starts with prop, and it's propan, and then ketones end in -one, as in this -one here. Okay, just like aldehydes end in al, which is this al here. Okay, so that ends in -one. Now normally you say, where is this ketone section, this section here? And if you think about it, that's 1 carbon, that's CH3, so it's 1, 2, so it's at position number 2, so it's propan to -one. So all I'm doing here is introducing you to using an R in your formula, and then recognising when R's exist because they are just alkyl groups, and then giving you some examples of each one of the different types of homologous series that occur throughout your AS or your first year of A-levels, and some clear examples of how to draw them. So what I would recommend that you do, stop the video now and try and draw a few and name a few yourself, looking at the rules that I've given. So now you have an appreciation of all the functional groups. Do not worry if you don't fully understand all of those, because we're going to do an individual video on every single one as we go forward. And we're going to talk about one type of compound here, which is cycloalkanes. Now that functional group, cycloalkanes, essentially has a ring. And that ring is also known as cyclic. And therefore it is inside the group of compounds called alicyclic compounds. So if you see any cycloalkane, you can refer to its type as an alicyclic compound. So how do we draw them? So first of all, we look at how many carbons is in there. Prop means 3. So we've drawn 1, 2, 3. Ane means it is an alkane, so single bonds only. And cyclo means you put it in a ring. Much easier to draw it in skeletal formula, and you'll find most of the time it's drawn in skeletal formula, and the questions that you get asked normally ask you to say how many atoms, for example, of each type are in that skeletal formula, or they ask you to recognise another type of cyclo compound, which is called benzene, which we'll talk about later. Now the next example is going to be cyclobutane. So again, in a ring because of cyclo, 4 carbons because of bute, and it's an alkane. So we see here, makes sense, 4 would be a square. If you're having cyclopentane, it would be a pentagon. Okay, would make sense, but a cyclohexane would be a hexagon. And there you have your hexagon. Notice how messy it looks with the structural formula, so generally we use skeletal. Now, types of hydrocarbons. We've already mentioned alicyclic, but let's talk about the first one, which is aliphatic. So aliphatic are just hydrocarbons that are in a chain, and they can have branches coming off, but they must be in a normal carbon chain. They can't have an aromatic ring. They're just a normal chain, no aromatic rings at all, and we'll talk about an aromatic ring again later. Now, alicyclic hydrocarbons are bonded in a ring with or without side chains. Now, this ring is a chain. So it's a chain folded round into a ring. That means that all alicyclic are in fact aliphatic as well, not the other way around. An aliphatic is not alicyclic because an aliphatic doesn't have to be in a ring. But the alicyclic are in a ring, but they're made out of a chain. And because they're made out of a chain, they're also aliphatic. And we'll go through a couple of examples of that later. But you notice cyclohexane is an example of alicyclic, and it's an example of aliphatic because the alicyclic are also aliphatic. The last one is an aromatic hydrocarbon, and that contains a benzene ring. And again, we'll go over what a benzene ring is by drawing it now. So aromatic, let's point that out in large letters there. So if you look here, aromatic includes this following structure. Okay, and the following structure is 3 double bonds within a hexagonal ring there. So it's hexagonal. And you can see here, 3 double bonds, hexagonal ring. Now, being aromatic in your A levels, you have to see that. If there's 2 double bonds, it's not aromatic. 1 double bond, not aromatic. It has to be 3 double bonds, and it has to be hexagon in your A levels for you to label it aromatic. As well as that, you can also see benzene drawn like that. So you can draw, it's drawn like a circle like that within a hexagon. So if you see this or you see that, you can say that is aromatic. And when they say what type of hydrocarbon is it, there you go. Right, we go for the next one. And we've got aliphatic, but remember, alicyclic is also aliphatic. So alicyclic is a ring. It's a chain, which is the definition for aliphatic, which is in a ring. So the alicyclic is also aliphatic, and that's because of this. All alicyclic are also aliphatic, and that's because this chain is in that ring. Now let's look at the different examples. So let's put something aliphatic. So an aliphatic might be like this. And you've got 1, 2, 3, 4, 5. And you can say, right, okay, it's branched or unbranched. So right now this is pentane and it's unbranched. But there we go. And we've got a branch there, which is a methyl. So that would be 1, 2, 3, 4, 5. And that would be 2-methyl pentane. So we've got 2-methyl pentane. And that's definitely aliphatic. Okay, it's not in a ring, so it can't be alicyclic, and it is a branched chain, and therefore it's aliphatic. We then look at this one, we say, right, let's take this, it's 5, and then draw it, and there is a pentagon. You can see a pentagon. From the pentagon, there's a methyl on 2. It doesn't matter where 2 is because we can start 1 anywhere. So I'm going to put 2 here. And we've taken this and we have turned it into a ring. And from that ring, we can see this is a methyl. So that has to be number 1 because that's where the methyl is. It makes sense to start number 1 there. And then we've got 3, 1, 2, 3, 4, 5. So this would be methyl. Okay, and you can call it 1 methyl if you want, but it's not really necessary. So 1 methyl, and it'd be cyclo. And it'd be cyclo, it's 5. So cyclopentane. So we've got this methyl pentane, which is aliphatic. We've got 1 methyl cyclopentane, which is aliphatic and alicyclic. Okay, so really important that you understand the distinction between those 3 and the fact that these alicyclic are all aliphatic. Our last example is to do with aromatic hydrocarbons and recognizing an aromatic hydrocarbon. So we know with an aromatic hydrocarbon you've got this benzene ring which you're looking for, which is these 3 double bonds within a hexagon. Okay, but I want to show you a couple of examples, and a couple of examples which can easily be thought to be aromatic and don't necessarily end up being aromatic, or they do. So I've got some examples right in front of you right now, and I want you to look at those right now and start thinking, right, okay, are those aromatic? Okay, are they not aromatic? Which one's which? Have a look, stop the video and write down what you think. Okay, so first of all, I've got to look for 3 double bonds in a hexagon. So there is 1 and there is 2 double bonds in that hexagon. So this is not, it's not aromatic, but it is a chain in a ring. So this is alicyclic. Okay, if it's alicyclic, what is it also? Well, it's also aliphatic because it's a chain in a ring. So you've got the chain, tick, and you've got the ring, tick. Okay, so that's good, but it's not aromatic. This, the circle tells you it's aromatic. If you see the circle within the hexagon, aromatic. Okay, so we then go to the next one, and we go for here, and we're looking again for 3 double bonds. Do we see the 3 double bonds? No, we don't. We see 2. So again, this is our alicyclic because it's in a ring. Okay, and it's also aliphatic. Okay, so this is easily done in a multiple choice question. Okay, and when we're looking at the exam style questions at the end of these this set of videos, you'll see an example of an MCQ just like this. But don't fall for it. It's only aromatic if you see the 3 double bonds or you see this circle within the hexagon. So 3 double bonds within a hexagon or this circle within the hexagon, which is the delocalized electrons. Not aromatic, but alicyclic and aliphatic, alicyclic and aliphatic.